Broadcast Depot, our co-sponsor for our Thursday virtual lunch gathering.
Hey there, and welcome to another edition of BD Inside. I'm Tim Job, and we're coming to you from the office of Broadcast Depot USA in sunny Tampa Bay, Florida. Today we are going to dive into the Diva DB7007 rebroadcast receiver, the features that it carries, and why it's the solution that you've been looking for. This equipment has been designed and is digitally tuned to repeat the broadcast of your station, reconstruct it, and apply or inject it into another transmitter and a different frequency. In the case that frequency A fails, the 7007 will hold another frequency in reserve and pass to frequency B upon failure. This unit makes it possible to receive audio as a backup option via AAC streaming, and you can even receive your audio via IP codec with the AAC, MP3, and PCM algorithms. If all else fails, the 7007 has an internal SD memory that will allow the storage of an MP3 playlist and, in real time, automatic changeover to this playlist in case all of the mentioned sources fail.
So there you have it. And Mary, Shelley,
I'm here.
Oh, good. Got anything to add, Mary?
No, it's a good box. So, and we're a master distributor for Diva. So if you have any Diva needs, contact me.
All right. Well, thank you. Glad you made it in. I'm also really glad to welcome Rich Redmond to us today. Rich is from BE Illinois, and he has agreed to help us benefit knowing about the new quick block transmitter and the features it has, the ability to do some really interesting things. Rich is welcoming your questions. If you press your spacebar or alternate A to unmute, or if you're on Zoom, as I see about a dozen or so of you are, just type in your message in the box there, the chat box, or here on Zoom, raise your hand, little thing at the bottom, or use the chat box, and we'll make sure that your question gets asked. So, Rich, we'll turn it over to you.
I had to unmute myself. Thanks, guys. I appreciate the opportunity to join. Let me see if I can share a screen here. Let's see, guys. Yep, looks like it's working. So we'll just step through a little bit today about the new quick block transmitter. I'll go through and talk a little bit about the high level architecture, a bit about RF amplification. We'll dive into with some exploded view diagrams of what's in the modules and the architecture, and kind of explain a bit more about what's inside. As Barry said, if you have questions, we're happy to take a shot at giving you an answer. So Elenos Group, some of you may be familiar with the company or at least parts of it. The group really has kind of four pillars, if you will. BE, probably best known in the US for AM, FM transmitters and audio storage systems and so forth. Also Marty STLs. Elenos, FM transmitters, compact, low power mostly, but we actually do up to 30 kilowatts in solid state transmitters. Telco is the genesis of the TV line that we make, solid state. And then Pro Television, which is kind of interesting. This was a company that was originally part of Philips and did the very first digital TV modulators for digital TV in Europe. And even before BE became part of the group, a lot of the digital correction for HD radio was done there. So we're fortunate to have pretty sophisticated in-house guys that do digital modulation for radio and for TV. The BE transmitters, we have AM up to 10 kilowatts, the STX from very low power, 60 watts up to 20 kilowatts in the portfolio. As I mentioned, we have a software suite of services, the Audio Vault. We launched Audio Vault 11 at the NAB. So some new features like offsite cloud storage, a seamless interface with Adobe Audition, and some additional scheduling capabilities. The other one that's been kind of interesting lately, while it's been around for a while, TRE, the radio experience, this is a piece of software that manages RDS text data. And stations now have been able to actually go sell, if you're a commercial station, sell the RDS text to like doctors, insurance companies, attorneys, and they found a new revenue source there. So I mentioned the Elenos transmitter from a few hundred watts and a couple RU up to 30 kilowatts in a single rack, all based on 5 kilowatt increments. The TV line goes up to 50 kilowatts in liquid and air cooled VHF and UHF. But really the thing we're here to talk about today is this product we launched at NAB called QuickBlock. It's a very modular transmitter that can be both very small and scale up quite a bit in power. And so I'll take you through some of the details there. The idea with QuickBlock is that it's really around 2 building blocks that we can stack up in a 3 RU chassis. So either, it could be a 5 kilowatt transmitter in 3 RU or 10 kilowatts in 6, but then these chassis continue to stack up to 50 kilowatts in a single 19-inch rack or any mix in between. So it's fairly flexible. Really some principles behind it are contemporary RF amplification and some flexibility on the exciters. Now, one of the interesting things behind kind of how we got here was really trying to understand what customers' feedback is on some of the challenges with transmitters. And, as we have more RF technical guys are, reaching retirement age, and a lot of younger technicians coming in, while maybe really sound in IT or low power RF, with the experience from, say, land mobile radio or cell networks, high power RF is becoming a bit more of a specialty. And so actually a couple of years ago, Gary Klein was having a conversation with our founder and owner, Leonardo Buzzi, and said, geez, it really would be great if you had a transmitter where the faulty device, could be pulled out and put in a box, and I could have a replacement, within a couple days via FedEx, because I have guys who can swap out modules, but I don't have so many guys that, know how to get inside and troubleshoot. And so that was kind of the preface, is in a 24/7 kind of environment, we've got the usual things, right? It wants to be up and robust. It's got to be cost effective. Ideally, it's got the ability to scale. So if I started with 10 kilowatts today and I got a power increase, could I just add pieces to get, higher power levels? So all of those things, become germane in what we tried to do. And of course, it's got to have the ability to connect to, internet. So we've got HTML5, secure browsers, and SNMP and so forth. So we talk a little bit about QuickBlock. Sometimes, you think about something and you go, well, what is it? And in this case, it's as much an architecture or a platform as it is a particular product. So we launched with FM, and that's what I'll go into more. But the platform is applicable, if you're a TV user, it can house VHF and UHF. In fact, as you would guess, the frequency and the space for FM is the largest of high band VHF or UHF. So fitting, television components inside actually becomes a little bit easier because the wavelength is shorter. So some of the principles that we've tried to hit, as I kind of mentioned, these small lightweight modules that can be pulled out, that are hot swappable. We tried to have a goodly amount of redundancy, but also compact, because for a long time, right, I could get a compact transmitter, but it kind of was like a high power exciter. And, Elenos really designed these in the ETG line, been very successful, works really well. But if I want to go repair it, I'm kind of taking the whole 5 kilowatt transmitter out, opening it up and doing it. There's not a lot of modularity there. So commonality of parts, modularity, and the ability to start analog and go digital. So, a lot of words here, but really the point was high power modular transmitters. Well, they've got a lot of benefits, right? Much more redundant, smaller units of repair. Usually I can hot plug things. So if I have a failure, I don't need to take it off the air. If something goes wrong, even if I'm not capable of repairing it locally, the thing I'm sending back is fairly small, and they get to quite high powers. In the case of a compact transmitter, it did have positives. It is very compact. It's easy to set up and purchase. There's not much assembly when you get it. You kind of hook up power and RF and an audio source and screw it into the rack, and away you go. You got to ground it, and there's some other caveats. But the point is, it's not like there are modules that have to go in a certain slot or a tube that you put in. They're quite straightforward. And so the goal was, how do you put all of those things into the product, but then actually remove all the things that's not so great about each one? I mean, the big modular transmitters are generally big. They've got a bigger footprint. You look for some guys, if you need a 50 kilowatt transmitter, it's several racks. It's got a much bigger floor space. And if you're in a place where either the building's really full or you're paying by the square foot, that all drives your costs. And so we tried to take, the benefits and kind of shed some of the things that were trade-offs. Same on the low side, we still wanted to be able to be compact, but being able to bring modularity and cost effectiveness to a compact platform has been a challenge until now. And we think we've kind of done a pretty good job. So this is a snapshot of the modules. The one on the left is the RF amplifier module, and we'll dig into what's inside these. The one on the right, sometimes you'll hear me call it an exciter module or a CCU, for like a command and control unit. This houses both the central controller, the user interface, the web browser control, and then dual exciters. So it packs quite a bit in. The modules are pretty small. They're just under 5 inches tall, so they fit in that 3RU chassis, and then about 3.5 inches wide. So we fit 5 modules across one of these chassis drawers, and they're fairly light, 15 pounds each. Now, the driver for a lot of the latest generation of TV transmitters and radio transmitters has come from the base station industry. So guys like Amplion and NXP have really been spending a lot of effort designing next generation LD-MOS devices. So there's a lot of really good things about this. I mean, probably the most dominant is you get a lot more watts per device than we ever did before. If you go back, a few generations, you may have, even one generation, you may have a 600 watt device, an 800 watt device. These devices are well over a kilowatt, in some cases reaching up to 2 kilowatts peak power. So that allows us to get rid of multiple stages of combining, which leads to, higher efficiencies. But there are also some other really important things. The increased gain. So the gain of these devices is much higher than in the past, over 22 dB of gain. And why that's kind of important is it allows us to have lower drive levels and not have to have huge IPAs. So again, earlier devices didn't have as much gain. You had to have multiple stages and bigger amounts of drive. The other kind of important thing is its lower thermal resistance. So when you have so much RF power in one device, you got to get the heat out to keep junction temperatures low. And so the thermal resistance has improved. It really allows us to extract the heat pretty nicely from these packages. And then when I say ruggedness, it's not so much as it physically rugged, but one of the challenges early on in solid state devices was that they were more susceptible for changes in load, right? We've kind of all had experience. You could run a tube transmitter into almost anything. Solid state's a bit more finicky. So there's been a lot of work on ruggedizing these devices. And where that starts to show up, it's not just things like iced antennas and Viswar, but when you start running digital amplification and you use pre-correction, The pre-corrector actually goes out there and kind of sweeps the passband, and it trains itself to do linearization. Well, if you have out of band a bit of this sweeping, you can get reflections that come back from, say, if you're in a combined system, a channel filter, or even from the antenna if it were more narrow band, and those reflections can be problematic to the device. So anyway, the point is, in today's devices, far more robust, and in fact, they're even going to higher voltages. So, we start to see 60-volt devices these days, which, for probably the past 15 to 20 years, 50-volt devices have been the most common. And the device manufacturers are now kind of stepping up. The higher voltage allows us to get to some of these higher powers and greater efficiencies. So we've actually designed the transmitter to take two different devices. This was kind of to mitigate supply chain challenges. So probably the device of choice is the one from Amplion, the ART 1K6, but it also works with the NXP 1K50. The 1K6 has a bit more power, but they're both, standard made devices, just very reliable. So this is what a module looks like. And so one of the important notes is it kind of breaks the paradigm a bit in that both the power supply and the control and the RF amplification are all in the same area. They're all in the removable device, the module. So, we've probably been able to remove RF amplifiers and then later power supplies for a long time. But unless you had a transmitter to test it in on the bench, or you had some way, a test fixture, it was hard to do a lot of troubleshooting because you still needed cooling, power supply, some control capability. But in this case, it's almost like the entire transmitter is on a module. The other thing that we've done is we've put the low pass filter at the module level. So this eliminates the single point of failure of a low pass filter. It also allows us to have a bit better efficiency of getting rid of those harmonics at a low level before they get to be more power. So it dissipates less heat. So here you can get a bit of a view of what it looks like inside. So the front cover, well, yes, it is kind of a cool looking extrusion. Actually, the shape of it was designed like the leading edge of an airplane wing, and it's adjusted so that it actually directs the air throughout here to have even distribution across the power supply and the RF section, as opposed to just a straight pull through. Now there's a magnetic cover that can snap on the front with a removable washable filter, if that's important in your site. But so there's a variable speed fan that's replaceable from the front, that provides cooling at the module level. The bottom is the switch mode power supply, and we can support either 50 or 60-volt devices from these. The mains comes in from the back, and then the top tier has both the APC power control and Visuar protection is at the module level, the amplifier, and then that kind of blue thing with the Swiss cheese holes in it is both a physical clamp that gets screwed down to provide equal pressure across the device. So it has equal solid pressure against the heat sink. So the heat sink's been removed on the exploded view. And that helps with the cooling as well. And then, through the low pass filter to the output connector. And so you'll notice there really aren't cables here. We're not sending RF through an edge card. It goes to a 7/8 inch EIA unflanged connector at the back that plugs into the combiner. And
so does this,
go ahead.
So does it, I take it all these will go through a combiner?
Yeah, so this is this gives you a bit more than 1 kilowatt mark. And so if you're, 4 of them get us 5 kilowatts. So that's in the 5 kilowatt. We have one module is the exciter controller, and then 4 PAs. And then, I think there are 9 and a 10. And then we go to the higher power. You just kind of keep adding these 3.5 RU drawers. So yeah, they go to a combiner at the back of the frame. Yep, you're spot on. And even in the combiner, it's all connectorized to connector and no cables, because eventually cables dry out and crack, and you end up with a failure. So we tried to eliminate failure points.
Why do the low pass filters look like removable fuses?
Yeah, that's a good question. I will be honest with you, Ken. I think, Ken, you're the one that asked the question. It's these coils here that kind of look like those off bug burning things, the green, that actually provide the coils. And I think this exploded view might have been an earlier one, because I don't remember these fuse cartridge looking things on the last one I looked at. They had more of this down here. So I can't, I'll be honest, I can't give you the exact answer on that, but I'll go ask. But the last one I took apart, because we have a metal cover over this, it was a combination of printed PC board strips on the substrate, and then these kind of coils here that are laser cut out of metal. So on the module, self-cooling, the cooling is in the module. So if there's a failure, it's at one module, it's not at the frame level. So that's easy to repair. Power supply comes out with the PA, low pass filters built in, as well as the protection. And then the modules all talk over a CAN bus to the frame level, and the frames talk to the central controller. But the communication is there more for central turn on, turn off in the web browser. All the protection and the APC is managed even down at the frame. So if the controller has an issue, it's not like you lose protection. The transmitter can kind of keep going.
Rich?
Yeah.
If you pulled a module out for servicing, does it go right into a dummy load? Does the browser come right to this single module that you can do maintenance or troubleshooting?
Yeah, so it can go into the dummy load. And then I think I've got a picture in here. We have a simple fixture that, we'll use in the factory, but will be available to customers, that it plugs in. So, and then it's got a little screen like the front of the transmitter, so you can do diagnostics on it. While we know some people are in the mode of, I'm going to send the box back and I just want to swap modules, we know other places people want to do local repairs. And so we tried to make a fixture available, Barry. And yeah, it runs right into a load.
I noticed it looks like a plug on the connection on the front inside the handle. Is that just like to monitor RF? No, if you go back to the other picture,
this one here. Oh, yeah, there is. Yeah. So there's a sample port.
Okay.
That you could use to put an analyzer on.
Okay.
Yes. So that is an option. And then the multicolor LEDs really can give you kind of that, usually I would always said red light, green light. There's a few other modes here. And there's some other combinations with flashing and so forth. But the point was to try to give you at a glance, without having to go to the screen, some quick diagnostics of where the faulty module is. Of course, the browser will tell you, and you can see that remotely before you get there. But the goal was, go ahead.
So for people like Steve Lockwood who are colorblind, there's a way to see that information quickly that isn't in color.
Yeah. From the front panel, it tells you all that same information. Yeah, this is kind of I kind of look at it as kind of a redundant mode. One is the LEDs, and then the other is the more traditional front panel or the remote browser. So you could look at it on your phone with the HTML browser, and it would tell you in text. It would spell out what it is. And then this is kind of more of just a fast, hey, there's a problem in this unit.
Ray has sent us a chat question. He says, does each module have VisWire foldback?
Yeah, that's a good question. So we have VisWire protection in a couple places. So there's what I usually think of as slow VisWire protection at the transmitter level. That's more of an automatic power control. The antenna ices, and it'll ramp the power up and down. At the module level, There's what I usually think of as fast Viswar protection that will make sure that the device is protected, so that if there were something in combiner that was problematic, or the other thing that sometimes happens is when you're combining this many modules, right, you go through a whole bunch of legs of a combiner. And as I found out with a TV transmitter, when you've got a bad elbow 1,000 feet in the air and you keep going, how come slot number 3 on the second rack keeps having module faults? Eventually you find out it's because that path had slightly less isolation than the other ports, because just of the way the hybrids stacked up, right? So yes, there's fast Viswar protection at each of the modules, so that if it has a problem, it'll ratchet back and not burn up. So this is kind of a quick snapshot of the home screen and the control module. I've got a few other screenshots as well, but it'll give you, specific values here. This is looking at some audio levels, the frequency, and there's some navigation. It's about the size of an iPhone screen. So it matches that footprint pretty well. So here's a snapshot of what's inside this. This a screen on the front is actually also a door. It tilts open. And in this case, because there's a lot less heat, there's a redundant fans at the back to pull the air through. We've got redundant power supplies in here and redundant drivers. So they're very low power drivers. And then this little card cage has the main controller, web browser server, and has dual exciters. And those exciters, have a switch over here with this back plane. Here's a little bit better view that's exploded. So you can kind of see the display hinges on the front door. The controller card is removable. And then in the back, we've got the cooling fans, we've got the redundant power supplies, and we've got the 1+1 redundant RF amplifiers. And then these are the exciter cards. We have two different versions of the exciter cards. So one is a kind of plain vanilla analog. It does have some audio processing capability in there. I think like a 3-band audio processor and stereo generator. And then the second is a more sophisticated digital modulator. So it'll do direct to channel, analog FM, and it can do HD radio. So you've got a choice. So if you want to start with one and upgrade, down the road, it's not like you've got to swap out a lot of stuff. It's a small card. And so, as I mentioned, there's multiple screens, but this can kind of give you an idea of, a screen that talks about audio levels and the forward power and some faults for the different amplifiers. You can navigate into some of these subsets, including the audio processing and so forth. Some different adjustments. I think this is for the tri-band processor. And then there's some readings like the temperature sensors and the different amplifiers and so forth. There's more screens. This just happened to be a couple of them that I grabbed. But as you would kind of expect, on the more sophisticated exciter, we can do EAS 192 direct in, HD radio or DRM plus. It can do SFN operation. We do have the ability to have GPS directly on the card for that. So you don't need an outboard GPS receiver, static or dynamic RDS. And then the multiple inputs, there's some failover selections. If you lost composite, it could go to backup left and right and so forth.
You go so far as to show like pilot injection or multiplex, subcarrier injection?
Yeah, my recollection is on this screen here. So there's modulation, the MPX inputs, and then it will also look at, if I'm not mistaken, what we're calling aux is the aux provides is the subcarrier input. But yeah, the kind of traditional things you have. Now, what I don't know, Ken, I'd have to double check. These are monitoring inputs. So generally, like if you're using an outboard stereo generator, they're scaling on it so that if you remove modulation, we can look at the pilot level, but it doesn't actually filter the pilot level out separately. For the internal stereo generator, we can look at the pilot level.
How about RDS?
Yeah, so yeah, both it's a great question. Both the basic analog exciter and the digital exciter have RDS that can do static or dynamic. So it's because I would say 10 years ago, RDS inside was kind of this intriguing option. Today, it's kind of like, I notice it when I drive to an area where like I drive a lot I live in Cincinnati, and I drive to Quincy a lot. And so when I drive through, it's almost like now when I'm on a station that doesn't have RDS, it stands out because it's missing, because a lot of places have done a nice job of at least having something about the station, but a goodly number have song artist and title, and then some really have a lot of additional information. So yeah, we kind of view that as a pretty important, kind of almost have to have. Thanks for the question. This gives you a little bit of idea of the size. So I mentioned before, the low power, it's 3 RUs across, gives us 5 kilowatts. The double of that in 6 RUs, we have 10 kilowatts, and then we do up to 50 in a standard rack. The other thing that we did have some customer feedback on, and we can support, is guys go, well, that's great. I don't need a 50, but I need 30. But to be honest with you, some companies' racks are kind of tall, and my particular site has a low ceiling, and I still need to get, the RF connection in and a conduit. So we can actually put these in kind of more mid-height racks, so they don't have to be the taller 44 or 45 RU racks, which generally a 50 or some other guys' boxes are in. We can be in a, more like a 35 or something like that. So if you're in a site where low ceilings are a challenge and you want a 20 or 30 kilowatt, we can do it in that size footprint. Here's a bit of a block diagram of what I was talking about. So over here is that, controller exciter module with the exciter switching and the dual drivers, which then goes to a splitter. So this is a block diagram of the single chassis, but it follows. And then in each module is where we have, cooling and protection, control, the RF amplification, forward and reflected power measurements, low pass filter, output coupler. And then if I'm not mistaken, as I recall, it's a little hard to read, but it's showing a 90-degree offset. And so by the combiner having 90-degree offset, it allows us to have a good return loss, so that if, you're getting something coming back down, it ends up canceling out, and, we end up not having spectrum regrowth. A little bit better shot here of the 3 RU chassis. The purple here in the back represents where the combiner is, and I'll just kind of cut forward. It's easier to see on this. But the modules, as I mentioned, here's where they plug into those blind mate 7/8 inch unflanged DIA connections. So there's like spring, ring finger stock around the edge for the ground, and then the central pin on the inside. This is all machined, so it's not, a PC board combiner. It's a machine and etch metal inside. The reject loads for each port are in here, and they're on this heat sink. You can kind of see a little blocker panel here, because in the all-in-one unit, there's not RF. But if this were 5 modules across, it'd be a 5-way combiner, and that's kind of where that goes. slots come in from the front, and there's a little bit of AC distribution. And if it's an all-in-one unit, this is where the IO is, and I'll show you the back panel in a minute. But pretty robust. And again, no cable combiners, and it's pretty lightweight. Here's a picture of the back of the all-in-one unit. So left and right AES EBU. We've got the main composite in the aux. This is where subcarriers generally go in. The 19 kilohertz monitor output. So like, if you're using the internal stereo generator. Here's a slot for the GPS antenna if we were using GPS inside, and 1 PPS and 10 megahertz outputs. Again, if you wanted to do SFN. AC connection is under a cover, so it's a terminal connection, not a specialized connector. And then general connections for things like the LAN. The CAN bus talks over an RS-485 and a CAN connection. So these are some other kind of internally when you're stacking them. And then there's GPIO logic for those who want to hook up to a Burke or something like that.
So your RDS would have to be multiplexed in with the multiplex input, as opposed to using the aux input.
No, my recollection is you can use either. Okay. I think you've got a choice there of bringing it in. So I think that's why it's called the aux. Is I believe my recollection in seeing the software was you could sum it in like a traditional pot for subcarrier injection, or it could also be used to switch as an input. But I can double check on that. And then things like the LAN connection allows you to get RDS data in to the subcarrier generator and some other things, if that's what you want. Now there is a USB connection that's allowed for programming, and especially if you had some specific RDS update that can go through there. The other thing is the external interlock is on a separate connector, so it's not buried inside a multi-pin connector. So if you want to, run that to a switch or a load, it's pretty straightforward. It doesn't have to be tied in with your remote control. Now, when I mentioned the single rack, there are a couple of things that are a little bit different than some others. You might think, okay, modular at 5 kilowatts, that's pretty unique. Here's a frame, 4 amplifiers, and the exciter. But the frame could also be configured to have 2 totally separate transmitters or set up in a 1+1 environment. So if you're in a space constrained situation and you have multiple carriers, maybe I've got multiple translators, or it's a low power backup, the frame's flexible. So we can, have that where there's multiple outputs on the back. It's a slightly different frame, of course, but all the same modules that are interchangeable. And, in this case, you could have a 2 kilowatt and a 1 kilowatt. You could potentially have shared RF modules. These things could be an N+1 or 1+1 scenario. And a goodly amount of that setup is already built into the controller for different frequencies and inputs. We probably see, to be fair, less of that here in North America, as we now have a lot more people running a lot more, translators. It is probably common that you get a bunch of translators at one site. Traditionally, we didn't have as much low power. Some parts of the world, a public service broadcaster like the BBC has 6 different networks. And so you might have 600-watt stations at a single site. And so having some modularity could be beneficial.
In that bottom one you showed on the previous page, could that be your analog higher power FM and then your 10th power HD?
Oh yeah, if you wanted to run and then do space combining, yeah, you sure could. Yeah, they could, because they could run any mode. So they could be the same frequency, and you could have, analog going to one and digital going to the other. So yeah. So I kind of say, it's like a building block approach. The exact application, builds up kind of like you're suggesting. It could be customer specific. And as you kind of might expect, if you lose an amp, there's a certain amount of headroom that you can, take up the rest of the amplifiers to allow you to unplug one and still make full power. So because we go in fairly small steps, primarily these 3 RU frames, I don't need to jump from 10 to 20 kilowatts, or I don't need to jump from 20 to 30. If I go, well, maybe I want to have 25 and give myself some headroom because my TPO is 19.5 kilowatts. I'd like some reserve. But geez, it would be kind of tough going to 30. So the idea is that, the modules can give you some reserve. If you lose a module, the defective module can be removed, and the reserve power keeps you on at your licensed TPO.
If you pulled a module out and its RF output connection was all burned up, so you have to take out that entire rack section, can that be done?
Yeah, so these, that's a good question. So everything on here, every combiner port, whether it's within a specific rack chassis, or these multiple rack chassis also they plug into a combiner in the back, all have their own reject loads. So that if you had to pull out a 3RU frame, if you will, then the rest of the transmitter could run, and there's a port based reject load for that port that handles the imbalance in the combiner. So yes, they can be. Now, in all fairness, taking the frame out, there's a wired power connection. It's not designed to be hot pluggable at the 3RU frame, but it is removable for repair, which is why when we talked about you could start with 4 of these and you could add 3 more for a power increase. It's because the combiner on the back is modular, and that it stacks up, and these are all keyed and plugged together, and the frames are interchangeable. So part of what makes the flexibility also allows you to get some configurations that aren't standard in some transmitters. Good question. Here's some snapshots of what's inside on these. So this is the one of the exciter cards. So this is an analog version of the exciter card that plugs inside. Here's a 3D drawing of the combiner that takes its 5-way in there. This is all machined, silver plated, and then these horizontal pieces are Teflon spacers. And then this is a hybrid combiner for 2 of the power blocks. And again, you can see it's all machined and stamped out with Teflon spacers. These are the actual RF inputs from 2 of the frames. So, fairly robust construction as compared to what you might see in some places. This was that test fixture I was talking about. And so the module, this indeed just plugs, this is a directional coupler, Barry, and then under the table, you can kind of see, I think it's a bird test load. So the 50 ohms really does just run to a load. And we've just made it up, because the power supply's in here, the mains just come up. So it feeds 220 volts into the module. And then this little controller allows you to do diagnostics on it. And, I think the protocol's available if you wanted to go do your own. My recollection is it wasn't incredibly expensive because there's not a lot to it. It's some AC distribution here, and I think just a little single board computer with this same screen that goes to the serial connections on the unit. Here's a picture of what's inside. So I think, Ken, you were asking about those other pieces. That's why I'm saying I think that was an earlier design, because each one I've taken apart lately looked just like this, where these coils were here and it didn't have those kind of resistor looking things. And then there's a metal box that covers this. So some of the circuit is printed here, and then the coils and so forth are there. And this is that clamp that on the rendering was blue, but the screw heads you can see here go right down through to hold the device in. So the device isn't soldered to the heat sink. The tabs, of course, solder for electrical connections, but this provides even pressure to make sure that it's got a snug fit to the heat sink for power dissipation. So this is what the 50 kilowatt looks like. Now, when we go to the high powers, we do have this option. If you want the little screen and the everything modulator, we can do that. But what we often do is run a 500 watt exciter that then provides the drive for all of this. So the two options are you use one of these controller modules and a pair of these for redundancy, these modules to drive it, or we can use what we are more familiar here in the US, kind of a standard X number of watt exciter, and then a little bit, the controller is packaged with a little bit bigger screen in a 3RU box. So if I'm at a higher power transmitter, I may want a bit bigger screen, and I may want to have more standard exciters. And so this is the power meter. We ran it up to, we were testing it just shy of 51 kilowatts on that in the plant. And I think, so yeah, I mean, I think really like the takeaway is it's in QuickBlock's a platform. While FM's the first launch for us, it can support others. You know, it's really designed to be very flexible and modular. So we're not trying to have different parts on a 1 kilowatt transmitter than a 5 or a 10 or a 50. And, you know, anyone who's supported a bunch of different transmitters knows, you know, saying I have a spare pallet, even from the same manufacturer, doesn't necessarily mean it goes in all of the transmitters. And in this case, it does. So if you had a spare module, what you're really saying is I've got a spare RF amplifier, I've got spare control, I've got a spare cooling, I have a spare power supply, and factually I have a spare little low pass filter. And if I've got a 1 kilowatt transmitter or a 50, they're the same with the controller and the exciter bits. Hot pluggability on virtually every part. Like I said, these 3RU frames pull out, but to be fair, you have to disconnect the power. The RF is a blind mate, so it really will pull out and plug back in. Very good efficiency. The digital correction and so forth is very good, coming from our TV line of digital exciters, and a significant amount of redundancy. So I think those are kind of the high points. So I'm happy to go back to any, we can go back and jump. Hey, when you were talking about this, I didn't totally get what you meant, or hey, that doesn't make any sense. Can you explain this more deeply to me?
Alan Kilgore was asking, what's in the bottom of the 50 kilowatt rack?
Oh, this is showing a AC distribution panel. That's a great question. So in this scenario, there's circuit breakers that provide AC power circuit breakers to each of these chassis. And then this is a bit more European in the drawing. The one that we do here doesn't have this, but a lot of guys in Europe, the network operators require a plug in the front of the transmitter with the idea that I wheel over my spectrum analyzer or my test gear, and I have to have a place to get power for it. So it's kind of common on this distribution panel. That's what this little tiny round hole is. We don't usually do that in North America, but the same idea of having US style breakers and AC distribution, the power goes to one place and it's distributed to all the frames, and there's a breaker generally driving each of these 3RU boxes. I'm assuming that's what you were asking about, was this piece down here.
Yeah, I got a question for you. You want to trade? Want to trade a 10 kilowatt one of these for my 10 kilowatt I just put in?
Well, yeah,
I'm impressed.
It is a pretty cool box.
Yeah.
Yeah, it's I have to say, when I kind of, you know, had the opportunity to learn a little bit more about this platform, and, you know, having lived some other lives at some other places, it's a well thought out, in my opinion, a pretty well thought out platform that tried to do a nice job of, look, if I've got skills and I want to be able to repair stuff, by all means, we want to make things repairable. You know, even down to, frankly, the switch mode power supplies are an Elenos design, and they have through hole parts. You can replace them. It's not a no schematics available off the shelf supply. And, you know, to be honest with you, there's lots of benefits of off the shelf supplies, and, you know, there are also challenges, but yeah, the goal was to do that. But then for the guys that need that, you know, Gary Klein's comment was, I want to send the receptionist. I don't know if we have receptionists at radio stations much anymore, but anyway, you know, someone of lower skills that, as long as they're not colorblind, can look for the colored lights and, you know, swap out something that came in a box. We tried to hit both ends, and I think the balance is pretty good. For sure, there'll be some place where, you know, we did something that didn't make sense and we'll have to adapt, but I think it's, my humble opinion, I think it's reasonably well thought out and pretty clever.
Do you have a backdoor open photo?
Yeah, you know, on this slide deck, I don't. I'm trying to think where I might have that. Hold on a second. Let's see.
While you're searching for that, I'll raise a question, Rich.
Uh-huh.
Has been come up, and that is that BE has had a reputation in recent years of not giving parts out to people, that they want people to send pieces of transmitters to them, and for contractors who want some parts, they can't get that. But with the quick block, I think you're intimating that the parts are much more available.
Oh, yeah, that's a good question. I mean, look, I'm sure there's some scenario. I can't speak universally, but I can tell you, every day I'm in the factory, we send boxes of parts out all the time. So I don't know. Now, one thing that probably most transmitter manufacturers hem-haw around about is, when someone says, can you tell me the OEM part number for that so I can get it from such and such a place? Usually, most of the time, we don't provide that. But if you said, I need R27 or I want something, we do have those. Now, we may push back a bit on sending FETs out and encouraging you to replace FETs in some of the designs, because the alignment's a bit tricky. But in this case, this one, that's a bit more straightforward. So I guess I would say, look, if somebody's having a hard time getting a part, I'm happy to go look into it for you and see if I can help you. But we don't have a policy that says I won't send you parts. There may be certain assemblies where we go, hey, there's, you know, nothing in there that's easy to repair, and so we do a module swap, like some of the older power supplies. But yeah, for this, for sure, the intention was to make it as serviceable as possible. Like I say, I'm not saying there's not a scenario where you can go on a, you know, FMI 3.5. There's a low pass filter board I tried to get and I couldn't. That may very well have been what had happened.
Well,
Are those
wasn't
cabinet
trying to be
fans?
snarky about it or anything like that. I just
No. I mean, I look, I'm happy with to address it. You know, we've all kind of been through that. Some things are just hard to get, and, you know, transmitter manufacturer guys usually don't charge a service and support fee, but do charge lots of money for spare parts.
especially right now with supplies and things like that being way out in time, it's a little harder sometimes to get the right parts.
Yeah, for sure. I'm sorry, someone was asking a question, I think.
We have several questions. John Mackey has a question here. John, you want to ask it?
Oh, I just wanted to ask, how good or how deep is the filtering when you're doing the low pass filtering on each module? And I noticed somebody else in the chat was raising a kind of sort of similar question. Have there been measurements done for cabinet RF radiation levels? I think we're both probably concerned about cell phone sites that are
Oh yeah,
trying to
10th order
restrict-
harmonic.
Right.
Yeah.
Or transmitters talking to each other.
Yeah. So the low pass filter, so there isn't an overall low pass filter in the transmitter. It's all done at the module. So it, meets both the European and the FCC regulations. Interestingly enough, when I was someplace else, so one of the things that drives people to put low pass filters at the module level is in the case of digital modulation, like we have in TV, a Doherty type amplifier tends to have a lot more higher order harmonics than we have in analog FM or class AB. And so it's actually very hard to filter those out once you're up at 5 or 10 or 20 kilowatts. So some of the guys like Roden Schwartz and some others actually put the low pass filters in the module because it's a lot easier to get deeper rejection at the lower power levels than when you're doing it at the output of the transmitter. And so when I was someplace else, we did that all at the output of the transmitter, and it was a bit more of a struggle. As far as your cabinet radiation question, we've done some of that, but I don't think we've done it at all the power levels. What we saw so far is meeting the performance. To your specific point though, on the cell phone guys, meeting the FCC rules aren't the hard part. It's the fact that they've got like 100 dB of gain on the front end and almost everything upsets their system, right? So they're often asking you to meet performance specs that are well beyond even what your requirements are, because the cabinet radiation specs aren't they're not oppressive.
That goes to the making sure you have a good lease that doesn't make you subject to dealing with the cell companies. They want to go right to the grass.
Yeah, then that's kind of where we had problems. And I did mess around previously on some tube rigs where we had to play around with different shielding inside the inside the box and all that. But generally on the newer stuff, a pretty good rack with a rear door and since all the combining is machined and we use the how we seal up the combining and the modules is pretty RF tight. Won't say there won't be something to mess with, but for the most part, it's been pretty solid.
Are those little fans in the modules, are those good high quality ball bearings that last a while?
Yeah, I don't remember which version it is, but it's one of the more common, like the name is right on the tip of my tongue. And so it's the same brand that get used in many of the other transmitter manufacturers, that they work fairly well. So I'm not saying that, well, I'll assure you it'll probably have a shorter life than, a blower on an FM 25K, because those, even though you'd go deaf around them, seem to last forever. But yeah, the fans that selected had, had pretty good shelf life of performance. Because yeah, I mean, it's like the last thing you want to do is be replacing those all the time. I'm hunting for this picture and I'm having a hard time laying my hand on it, but I did have a picture of the back door and it had the combiner in the 50. So I'm sorry I don't have it right. Oh, hold on. Maybe I got it here.
I saw the transmitter at the NAB, but I don't recall looking in the back of it.
Yeah, it's no, I guess I don't have it on this picture. So the combiner in the back is yeah, that's disappointing because I did have it someplace. Sorry, guys. It's a machined, so much like the combiner I was showing you inside the drawer, where it's got the interconductor, and then it's a machined enclosure. This combiner is somewhat similar in that it comes in, I think, two chassis increments. And so it kind of stacks up in almost like a progressive combiner where it takes a couple of inputs at a time, all machined aluminum, bolts together. And then in this assembly is the combiner, the splitter for drive, and the reject loads for every port. And so it bolts onto the back of it. There's a standoff that takes you away from the back of the box to allow for air to go up and out the top. And then it's a machine. So it takes up about half to a third of the width of the back of the rack. And then the other half is open. And that's where you see the power distribution, but the heat comes out the back and then goes up the top. And then there's a cabinet flushing fan at the top. It's like maybe a 12 to 15 inch fan. It's a pretty big fan at the top. In fact, I think, Mark, it's about the same size fan, right? There's a fairly large fan at the top of the rack on your 10, even though it's in that small cabinet. I think that's got a cabinet flushing fan that's fairly large at the top. It's similar to that. Oh, sorry, I don't have a picture handy, guys. But it's not RF plumbing and separate reject loads and all that. It's a machined piece, stacks up in a series, and picks up 2 of those 3 RU frames at a time. It's got a standoff of a number of inches from the back of the box to allow an air channel for air to go up and out the top. And the reject load, the power splitter, and the power combiner are all there. And then the RF outputs at the top with a directional coupler.
Hey, Rich, I just have a quick couple of questions.
Sure.
Regarding the RF amp.
Uh-huh.
So you mentioned something about how the amazing things they've done in your TV division with digital things with these modern devices. So my question, I guess, is what kind of a PA efficiency are you achieving in that amp at this point? And I'm specifically asking if you're fooling around with advanced drive strategies of driving the gates of the MOSFETs, the LD MOSFETs, so that they get higher efficiencies. I know people do that in the switching power supply energy thing.
Yeah, that's a good question. So in these cases, so overall AC to RF efficiencies, right around 76% AC to RF efficient, depending on which model you're at. It's a little bit different. So, that means we're, up in the mid 80s at the PA level, to make up for some of the other losses. In this case, in FM, it's, I would say, fairly straightforward. The Doherty design that we do for digital in a digital TV environment, it would be applicable in FM if you were running all digital, like all digital HD or DRM. But once you have the big analog component in the middle, you lose the efficiency benefit. So because generally in those cases, you're saying, well, I have high peaks, but there's not a lot of energy there. So I have an average amplifier and the peak amplifier because they're in pairs in Doherty. But for, say, HD radio doesn't really help us there. And for analog doesn't really help us. The thing that you are talking about with the gate drive and so forth is something that I guess I'll just say, some of you may know Tim Hardy, who had been at Nautel for a long time, heading up their engineering, joined our group last fall. And so Tim's busily engaged on something that would be applicable there. And, an AM transmitter is a lot like a big switch mode power supply in some cases. So we don't do anything with a gate drive in the FM or the TV space. TV's more is the Doherty approach. We do share pre-correction, which helps us when it's digital, the peak clipping and the linearization. But otherwise it's a Class C operation for FM.
Okay.
Did that answer your question?
Yeah, it does. And the other thing I wanted to ask was, the beauty of this sounds like, well, you have the built-in power supplies for each module. So you're able to do precise voltage control of the devices? Because as great as the LD MOSs are, they do sometimes suffer from thermal drift as they heat up, and so the power starts to droop a little bit. But you can take care of that just precisely, right?
Yeah, there's control right there on the module that is able to, so the controller is managing the power supply, the RF, it's managing the protection of the RF, and it's managing thermal. So the thermal control is not away from it. It's in fact the control, and the fan is very near the source of the heat. So it's really to try to make that, it's a transmitter and a module. I mean, if you had a 1 kilowatt transmitter, you really just add drive, because most of the rest of it is inside the module.
Right, right. I just have one real quick comment too, which is I think is blowing everybody away here. In as much as the rack or the chassis is mostly just a holder for modules. You don't have a lot of little power supplies screwed to the sides of the cabinet, right?
Yeah.
doing other little housekeeping tasks. It's almost completely self-contained within two types of modules, RF and CCU.
Yeah, that was kind of the objective, was to have a minimal amount of stuff in the rack, because it gets back to that maintenance issue, right? That it's like somebody who has a multimeter in their bag and can go do circuit level troubleshooting to find out that there's a power supply tucked inside or some other controller board. We don't have as many of those guys. And so the goal was to make everything as hot pluggable as possible. So yeah, for sure, there's a little board that has the communication, and yes, there is a power, AC power input, but those things are less likely to fail. The goal was really to have as many of them, as many of these available to be hot swapped.
Yeah, somebody mentioned earlier in a question as to whether you were going to do an AM transmitter of a version of this someday.
Yeah, so I would say, yeah, look, it's on the roadmap. So my hedge, let me answer the question this way. You will see us do some advancements in AM. Because of the size of the components, it probably doesn't fit exactly in this format, right? Because combining on AM is a bit different, and the size of the components for the frequency aren't quite as small. But the concept of trying to have it modular and not as much stuff tacked inside the box, will be similar. But usually combining modules in AM is copper pipe, fairly large coils, and some big capacitors, and kind of physics dictates that. But from a standpoint of a significantly shrunk footprint and very high efficiency, there's some interesting pulse step modulation capabilities that break you away from traditional PDM, which create, those amplifiers at the pallet level are like, geez, 99% efficient, because they're almost like a big switch mode power supply. So when you're doing pulse step modulation in AM, which might be similar to what the old DX was versus PDM, you're really turning on and off a bunch of amplifiers or fractional amplifiers to create the envelope. And so the devices available today in gallium nitride or in it's I want to say carbon, but the exact name's slipping my mind now. GaN would be more high frequency. At low frequency, anyway, the point is, these devices that come from electric cars and big power supplies are applicable to AM. And so while I wouldn't say it's going to be exactly like Quick Block, it's going to have a lot of the same principles, meaning a power module is probably not going to fit in 5 inches by 3.5 inches, just because of some of the bits that go with it. The frequency determining pieces are a bit bigger, but they're still really, really small.
Sounds great.
Silicon carbide. Thank you. I had a brain freeze. I think that was Joel. Yes, that's exactly what I was trying to say.
You have a question also from Randy Henry there.
Hey, Randy. Oh, do I have to click on something? I'm sorry.
Oh, he's in the chat box. He's
Let's
on
see.
Zoom.
Chat. There we go.
He's on the YouTube link.
Sorry, I didn't have the chat box up. Randy. Yeah, so we will be shipping first the 5 and then the 10 starting in Q4. So I would say, to be fair, a 5 or 10 kilowatts going to be, somewhere around the November to January timeframe. Off the top of my head, I would say 5 kilowatts are generally under 20K, and 10 kilowatts are generally under 30K street price. I mean, there's a higher list price, and then there's a discount and all that. But so I would say 5 kilowatts are in the mid to upper teens, and mid to upper 20s are the 10 kilowatt.
Do you publish your brother-in-law's names?
My brother's names. Oh, not always, no. So I would say, so anyway, these can be strapped for single or 3-phase. So each power supply module is actually a single phase supply, but then at the AC distribution, it could be set up for single or 3-phase, just how you what the distribution looks like.
So for those AC distribution modules or components, those are only needed for 10 kilowatts and up? Is that, or?
Oh, no, I guess what
okay.
Yeah. So I guess all I meant is, when you're doing 3-phase, yeah, if you wanted to do 3-phase, that's usually where, yeah. So on the 10 and the 5, we usually just connect right to the back of the chassis. And it can be strapped for single or 3-phase. But then when we have the multiple chassis, like let's say a 15 up to 50, that's where we do the breaker disconnect panel. And in there, kind of how you basically you split all the single phase loads as equally as you can across the 3 phases. So that's where that distribution panel comes in. If you wanted it for lower power, you could have it. But our intention is you could put it in, or, you could get a 10 kilowatt in your own rack. It's not very big.
So I saw where the individual modules are about 20 inches deep, but plus there's all the backplane stuff. So what's the total depth of a?
Yeah, I wanted to say it was around 30 inches. So, a more, so if you've got like an older style 25-inch deep rack, then, this is going to be a bit more limiting. If you've got kind of a more contemporary server rack, or a, 36-inch deep rack, then those are about the size these fit in pretty handily. I don't remember the exact depth of the one we showed, but they are a bit deeper than, some of the earlier ones. So if you, like I say, if you've got older racks at your site, then this would stick out the back. Or we can provide a rack.
Anyone else have a question for Rich about the quick block, either the whole transmitter or the components?
I guess my last question is, what is the largest single component in, like, or the heaviest single component in all of this? If, for example, if I already had equipment racks on top of a mountain, I have hauled equipment up mountains in the wintertime on a sled or something, and being able to break it down into individual weights.
Yeah, so the modules are each 14
15
pounds. Yeah. And so I guess it depends how big the frame is. So if you're on a mountaintop, I guess unless you're a really high power station, you're probably 20 kilowatts or less transmitter power TPO. Are you thinking?
Yes.
Right. So I want to say those frames without modules in them are only marginally heavier than the modules. So probably the rack ends up being the single heaviest thing. If you already have the rack, then like a 10 kilowatt transmitter, it doesn't become unwieldy. We had a discussion with some engineers from Vermont Public Radio who were at the NAB, and one of them was, her frame of reference was Crown transmitters that, she described exactly what you had said, that, having to try to put that in a backpack and get on a snowmobile and take it off the mountain and going back was pretty rough. So she was there kind of lifting both the entire frame and the modules. I think we pulled all the modules out and she was lifting the frame to kind of get a sense of how tough this would be. And so she kind of felt like it was light years ahead of what she was dealing with. So, well, I don't remember the exact weights. My recollection was the empty 3RU frame was not substantially heavier than the module. A little bit,
So
maybe
a
25
side benefit,
pounds.
yeah. So a side benefit of that is, even if you didn't have to have similar conditions to that a single person can mount it and screw it in themselves and then just keep adding the modules to it.
Oh yeah. Yeah. I'm glad you point that out. A number of years ago when I first went to work at Harris, they sold a transmitter called a Quest. It was a 1 kilowatt transmitter that had linear power supplies in it, solid state, but it was super heavy. And after having installed one before I went to work there, I was in the factory one day and I go, guys, I just have to ask you, how in the world do you put this in a rack? Because it's incredibly heavy. And they said, well, you just put the transmitter on the forklift and then you drive it into the rack and then you put the screws in. And so I had to explain to them that I didn't know anyone who had a transmitter site with a 1 kilowatt transmitter who had a forklift. And they seemed to think in the factory that everyone would have one. So yeah, that is a challenge when stuff gets so heavy. But in this case, it breaks down. So it, for sure, even if you're not backpacking, it's a bit easier to get in a rack than some other things that are a bit more unwieldy. I'm happy to always, if anyone wants to reach out, just rich@elenosgroup.com. And, look, if there's something you're trying to get some technical help on, I'd be glad to get you the right person. Or if there's further follow-up questions, I'm glad to help as well.
Here's one last question here as regarding network web server.
Yeah, so the transmitter has both SNMP and HTML5 built in, and it'll serve up a web display that you can access from a mobile device or from a laptop or whatever. The SNMP is kind of nice if you use any sort of network manager or don't want to do a parallel wired interface. I don't know if I answered the question, but yes, there is a browser built in.
Very good. Rich, thank you. You've given us almost an hour and a half here of your time, and I appreciate that very much. And
oh no, we appreciate the opportunity. And look, whether it's this or there's like I say, we've got AM transmitters up to 10 kilowatts. We have various low power transmitters and HD or analog. So we're happy to help. Even if you just go, I've got a 30-year-old rig and I'm having a problem, we can get the service guys to see if we can't help solve the problem for you. So
and I want to make clear that my question earlier about parts availability, that was prior to the Elenos.
Yeah, and look, every place goes through those gyrations, and I'm sure there was probably some time that there was some scenario that someone said, we're not going to go do that, but it's not a general policy. I mean, we're happy to provide parts. Again, I don't know what the specifics on that might be. And I have no doubt that someone experienced that in some way. But we generally try to provide them. There are some things that are more problematic. I don't know. One thing that we did do for any of you that may have had older STX LP units that had the now discontinued Tektrol supply. Tim Hardy's actually developed a replacement of that for us that's module compatible. So not only do we have a repair plan where if you want to send back the old one, we'll send you a new one or a rebuilt one, because we've had some success getting them rebuilt. We actually built a module frame that takes a fairly standard compatible mean well supply and then put the appropriate logic and connectors on it so you can hot plug it and put it in. So if you have a STX1 through 5 LP that had Tektrol supplies, we do still have some Tektrol supplies in stock for replacements, but we also have built a module compatible replacement. So you don't need to change anything on the transmitter. It's just a fit, form, and function plug-in. So we do try to have some ongoing support even when the guys who make our parts go away.
Well, again, we're not chasing you away by anything.
No, thanks, guys. Appreciate all the questions.